question. If a cost function cx is this, then we have to find the marginal cost when existent. So first of all, what is the marginal cost? Marginal cost. So marginal cost is nothing but the derivative of the cost function, or the first derivative of the cost function. So that's what we need to find. You need to find d over dx of 100 natural log of x over 40 minus 3x. So 100 is a constant, it comes out. So we have a d over dx of natural log of x over 40 minus 3x. The differentiation of ln x over 40 minus x is, we gotta use the quotient rule. So we have the denominator square, and we have the denominator times the differentiation of numerator, as in the differentiation of ln x, minus the numerator, which is ln x, and then we have the differentiation of denominator, which is 40 minus 3x. So that's how it is. So here we already have 100, and then we have 40 minus 3x, and the differentiation of ln x is 1 over x minus natural log of x. Then we have the differentiation of 40 is 0, minus 3 comes out, and differentiation of x is just 1. So I'm gonna write just minus 3 over 40 minus 3x whole square. So I think it's a good time that we can replace x by tan, because we need to find the marginal cost at x equal to 10. So that's what I'm gonna do over here. We have c dash x as this value. So c dash at x equal to 10. So we have c dash 10 is going to be 100. 10 times 3 is 30, and 40 minus 30 is 10. So we have 10 over 10 minus natural log of 10, and we have minus 3 already, over this is 40 minus 30, which is again 10. So we have 10 square over here. So this is 100, then 10 over 10 is 1. So we have 1 minus, and minus will become plus. So 1 plus 3 ln 10 over 100. So this 100 and 100 fortunately is cancelled, and the marginal cost comes out as the final answer as 1 plus 3 ln 10. If we are interested in a decimal approximation, let me just grab my calculator. So ln 10 times 3 plus 1 is coming as 7.91 up to 2 decimal places. So this is the marginal cost for x equal to 10. Thank you.